Hey everyone, and welcome to The Explainer. Today, we're diving into a massive clash of ideas at the absolute bleeding edge of artificial intelligence. On one side, we have Andrej Karpathy. He's a true pioneer in the field, and he's detailing this massive paradigm shift in how we interact with computers, a shift he calls the Software 3.0 vision. But on the flip side, we have Daniel Miessler, who brings a much sharper, economically driven critique. Miessler argues that Karpathy's timeline for artificial general intelligence, or AGI, might actually be dangerously underestimating just how soon everyday jobs are going to be impacted. So we're going to unpack both of these perspectives today, using data directly from these thinkers to figure out what our future actually looks like. Okay, let's dive right in. If you really want to understand where tech is heading, you have to grasp this fundamental shift in how we build things. Karpathy actually captured this perfectly with one simple, profound quote. The hottest new programming language is English. Think about that for a second. We aren't just writing rigid syntax for machines to interpret anymore. We're literally just talking to them. English is the new code. It's a total paradigm shift, and honestly, it sets the perfect stage for understanding this massive leap into Software 3.0.
Here's our roadmap for today. First, we'll track the evolution of software. Second, we're going to explore Karpathy's concept of the LLM operating system. Third, we'll talk about the strategy of building Iron Man suits. Fourth, we'll pivot to Daniel Miessler's critique and redefine the AGI timeline. And finally, we'll pit systems versus average workers to get a real sense of the timeline for job replacement. Let's get started.
Part 1. The evolution of software, moving from explicit code to natural language.
So Karpathy breaks down our software history into three distinct eras. We started way back in the 1940s with Software 1.0. This is your traditional software, where engineers are sitting there writing explicit line-by-line instructions. Think of all those legacy systems that are actually still running much of the world today. Then, right around the 2010s, we shifted into Software 2.0. This is where neural networks started optimizing weights based on just vast amounts of data. And now, welcome to the 2020s. We've arrived at Software 3.0, the AI-native era, driven completely by prompts and large language models. It is wild to realize that natural language itself is now the programming code.
What's really fascinating here is how incredibly practical this transition already is. This isn't just some abstract theory. Back when Karpathy was the director of AI at Tesla, he notoriously watched Software 2.0, and neural networks progressively just eat right through traditional rigid C++ code in their autopilot system. Tasks that human engineers were painstakingly trying to hand code with explicit rules were suddenly being handled way better by machine learning. Now Software 3.0 takes that even further, turning the actual execution entirely over to natural language prompting.
Moving on to Section 2, the LLM operating system and rethinking computing architecture.
Karpathy argues something super profound here. An LLM isn't just a chatbot or some simple API. It is essentially an emerging operating system. When you look at the architecture side by side, the parallels are stunning. It's totally a light bulb moment. In a traditional OS, your CPU handles processing, right? Well, in an LLM OS, the model's reasoning capabilities act as that CPU. Your traditional RAM becomes the LLM's context window. That's the short-term memory it holds while you're chatting with it. And the traditional file system or hard drive, that becomes RAG, or Retrieval Augmented Generation, where the AI pulls saved external knowledge right into its workflow. Karpathy actually compares this to the 1960s time-sharing era of mainframes, where computing resources are centralized, incredibly expensive, and we just access them via these simple chat terminals.
But here's the catch. To use this new OS, we have to understand its psychology. Karpathy describes these LLMs as fallible savants with very specific, kind of weird cognitive quirks. First off, they suffer from hallucinations, meaning they'll just confidently invent facts. Second, they possess a jagged intelligence. This means they can perform absolute superhuman feats of logic, but then completely fail at a task a toddler could figure out. Third, they have anterograde amnesia, which means their memory just vanishes outside of that active context window. And finally, gullibility. They are highly susceptible to malicious prompt injection. So designing for Software 3.0 means actively building around these exact quirks.
Which brings us to Section 3, building Iron Man suits and augmenting human experts. So what's the game plan? Well, instead of getting caught up in the sci-fi hype of building completely autonomous, perfect robots, we need to focus on building Iron Man suits. What does that actually mean? It means partial autonomy. Karpathy champions this idea of an autonomy slider. It's a user interface concept where a human can dynamically slide and control the level of AI intervention. It creates this highly efficient loop of AI generation followed instantly by human verification. It is not about replacing you. It's about giving you superpowers. But to build these suits, our digital world needs a serious infrastructure overhaul. We have to transition away from a web built just for humans to a human and agent-native design. Practically speaking, Karpathy suggests we need to refactor our documentation. So instead of a button that just says click here, we provide executable curl commands that an AI agent can just grab and run. It means creating new standards, like an lms.txt file, which provides explicit, machine-readable guidance directly to the AI agents that are traversing your site. We are essentially rebuilding the internet so that AI agents can browse it exactly like we do.
All right, pivoting to Section 4, redefining the AGI timeline, and Daniel Miessler's critique.
Now, this is where Daniel Miessler steps in with a huge reality check. He argues Karpathy's 10-year timeline might be missing the forest for the trees, and it all boils down to definitions. The definition Karpathy relies on, which comes from his time at OpenAI, defines AGI as an AI that can do literally any economically valuable work as good or better than a human. It's a pure, almost academic computer science definition. And yeah, under that extremely strict benchmark where an AI must be perfectly general and flawlessly execute any task seamlessly, we probably are a decade away.
But Miessler, he looks at this through a purely economic lens. His definition of AGI is so much simpler, an AI system that can replace an average knowledge worker. Why does that matter? Because everyday people don't care about the purity of a computer science definition. We care about our livelihoods. This definition shifts the benchmark directly to actual human job replacement. And under this definition, Miessler argues, AGI is coming much, much faster than 10 years.
Miessler makes a great point here. As a pure AI researcher, Karpathy intimately knows all the flaws and limitations of the raw models. But in the real world, AI systems are not just naked neural networks. When you interact with advanced tools today, you're interacting with an LLM that has been wrapped up in colossal engineering scaffolding. Take Anthropic's Claude Code, for example. By adding agent skills and a framework for the AI to talk to itself, manage its own context, and coordinate tasks, its performance radically improves. The surrounding system basically works around the pure limitations of the model itself.
Finally, Section 5, Systems versus Average Workers and the Cold Reality of Worker Replacement. Miessler makes a pretty chilling observation here. These multi-billion-dollar AI startups aren't trying to build systems to replace the top 10% of hyper-productive, absolute experts. No, they are competing with the baseline mediocrity of the bottom 50% of knowledge workers. If you consider workers who just do the bare minimum, who detest their jobs, or who just mindlessly punch in and punch out every day, that is actually a remarkably low standard for a composite AI system to meet.
And that brings us to this very real, creeping threat, the ratchet effect. Think about the timeline since ChatGPT launched. How much have the bottom 50% of human knowledge workers improved their daily capabilities in that time? The answer is effectively 0%. Meanwhile, composite AI systems are seeing compounding, massive improvements. We are literally comparing a static bar of human mediocrity against an AI system that is advancing at a staggering, exponential rate. You know, it's easy to think, well, that's just the bottom tier. I'll be totally fine. But when you actually look at the math, it is staggering. Globally, there are roughly 1 billion knowledge workers. If AI systems only hit the threshold to eat the absolute worst, bottom 50% of knowledge workers in the next 5 to 10 years, that still equates to hundreds of millions of jobs disappearing. Even a partial AGI, based on Miessler's definition, completely disrupts the global economy. So, just to summarize this massive incoming wave, AI progress relies on multiplicative improvements. Right now, our AI research pipelines are often held together by digital duct tape, but as they formalize, an efficiency tweak in just one area multiplies across the entire system. The standard required to replace mediocre, baseline human work is incredibly low. And crucially, there are literally trillions of dollars currently being invested right now with one single goal: making these systems just general enough to replace static human labor.
So here we are at a massive crossroads, defined by Software 3.0. Karpathy is absolutely right that the technology is shifting to this English-driven LLM operating system. But Miessler is also right that this system doesn't need to be perfectly flawless to completely upend the workforce. The technology is already here, it is scaling fast, and it is firmly targeting the baseline of human knowledge work. Which leaves you with one deeply personal question to ponder as we move forward into this new era. Will you learn to wear the Iron Man suit, or will you be replaced by it?